All right, hey everyone. You should be in group 3, sitting with a partner, listening and watching this video. So as I go through these slides, I just want to make sure you're paying attention. So read along with me and I'll read through the first couple slides. So the directions for this task today, you'll be working on, you'll have 10 tasks, so 10 different cards to complete with various questions on each one. You must answer all parts before moving on to the next task, and the partner team with the most tasks at the end of the hour wins. Just a reminder though, you'll want to watch these videos for each slide before you begin. Each person needs to complete their own answer sheet. So if there's 2 people together working on these tasks, each one of you will have your own sheet. You can work together, but you will both turn in a sheet. Make sure your name is on it. When you are done and have completed all the tasks, all 10 tasks, and every question on each task, write Mrs. JC rocks on the homework board and sit back down. All right, you may begin. You probably want to take notes. No, seriously, where's your notebook and your pencil? I'll wait. Do you have it out? Okay, these are going to be really great notes to take. They're going to push you but challenge you in a good way. So make sure you have a great growth mindset. So this slide I've put on here just to give you a little bit of insight on composite functions. And these functions, if you look right here, these functions are, I'll highlight it. They're composites or compositions of functions is when one function is inside of another function. So one thing that is important on this slide, and you can read over and pause the video, but if the notation looks like this, those 2 pieces of notation are equivalent. So I'll give you a couple examples on the other slide, but if it says, and I'll kind of point to it, if it says F with this little, let's see here. If it says F with a little circle and G and then the X, that is the same thing as evaluating G of X and then the answer taking the function F of that answer. So if it looks like this, that's going to be the same thing as it written as in this case. So the first thing, if you look at the bottom of this page, it gives you a little bit of notes. The first thing is to rewrite it in a different form. So for example, it says the composition needs to be rewritten as that. So you can go back to this slide and kind of review some of the things that it goes over. But on the next slide, I'm going to give you an example. So here are 2 functions. It says h of x equals x squared plus 3, and then f of x equals negative 3x. So what I want you to do is I want you to find h of f when x equals 1. So if we look at back on the last slide, the first thing we need to do is we need to rewrite this notation as h and then of f of 1. So we're going to do, it's a function inside of a function. So the first thing we have to do is we have to find f of 1. So all I did is I took the second function, and that's the one I'm doing first. So I have to find f of 1. So I'm going to look at my function f, and I'm going to do f of 1 equals, and then remember we're replacing all of the x's with my input, which is 1. So f of 1 equals negative 3 times 1, which is negative 3. So now that I have f of 1, I can plug that back in this location for that f of 1. So now I need to find h of my answer, which is negative 3. And h of negative 3, now we're going to look at our function h and plug in negative 3 as the input. So I'll do that right here. H of negative 3 equals negative 3. I'm going to rewrite it so that we can see this clearly. So h of negative 3 equals negative 3 squared plus 3. So remember, all I did was I took my h function, and instead of the x here and here, I'm plugging in my -3 because that's the answer that I got when I did f of 1. So now I have -3 squared, which is -3 times -3, which is 9, and 9 plus 3, which is 12. So the answer to this is 12. So now another example, you might have functions written in different representations. So in the last slide, we had 2 equations for the functions, but here, as you can see, we have a XY table. And remember, the y as an output is also represented as f of x. So we have our XY table with various inputs and outputs. And then we also have a word problem that doesn't explicitly tell you the function, but we can write a function for that. So let's start with this word problem here. It says Joe gets paid $9 per hour plus a bonus of $20. His total pay is the equation for P of X. So for this, if we look at this word problem, he's getting paid $9 per hour, and that can be written as 9 times x depending on the hour, how many hours, plus the bonus of $20. And we're going to call this function P of x. So remember learning about slope and y-intercept being the one-time amount. That would be our $20 here. So that's why that's the y-intercept. And then $9 per hour is our slope. So that goes with the x. So now that I have both functions, let's look at what it says. It says evaluate P of f of 4. So I'm going to do this part in the middle here first. So I'm going to do f of 4 first, and then I'll put my answer in there. So f of 4, I'm going to use this function because it's represented as f of x. So if I find f of 4, it's not on the chart, but I know if I keep going, the x's increases by 1, then the y's look like they're all increasing by 5. So if I add another 5, my output here will be 30. So I know when I plug in 4 into my function for f, I'm going to get 30 as an output. So now that I know that f of 4 is 30. So now I'm looking for P of 30. And now since I'm looking at and using function P, I'm going to use the equation over here, and I'm plugging 30 in for my input. So P of 30 equals 9 times 30 plus 20. Remember, order of operations, we do the multiplication before the addition. 9 times 30 is 270, plus 20 is 290. Okay, for this example, we see that we have 3x plus 1. This function is written as an equation, and then function g, as you can tell, is a graph over here. It's labeled g of x, so I know this is my function g. So 2 functions, function h, function g, and here's my problem. I want you to find h of g of 2. So I have to find g of 2 before I can find h of that input. So I'm going to find g of 2, which means I'm using function g, which is the graph. So finding g of 2 is my input. So I'm going to use my x-axis. I'm going to go over to an input of 2, and now I'm looking at where I run into the function. So it's not up here. There's no function up there, so I'm going to follow it down, and I'm going to stop when I run into the function. And when g is 2, the output here is -4. So I know that g of 2 is -4. That's my output. And now I can find h of negative 4. And so I'm going to rewrite my function that I have listed at the top, 3x plus 1, and I'm going to take my negative 4 as an input and solve it with using order of operations. So multiplication for addition, 3 times negative 4 is negative 12, plus 1 is negative 11. All right, so now we see operations on these functions. So it's a little bit different notation. This is definitely going to be something that you want to pause and write in your notes. So I would write operations on functions at the top. So this is what it looks like when we have these operations involving multiple functions. So if we see a f plus g and then the x as the input, this is the same thing as taking function f and adding it to function g. So just to clarify, this left side is notation, but it's the same thing as this right side, just written differently. So you're going to want to write down these rules in your notes, and just remember that if it has an addition between the two functions, it just means we're taking the first function and we're adding the second function. Same thing for subtraction, multiplication, and division. So go ahead and take a minute, finish up copying these in your notes, and then on the next slide I'll go over some examples. All right, so here's an example where I see function g. It says g of x, let me add my equal sign in there, equals x squared minus 1. And then I have function h of x equals negative 2x plus 1. So here are my two functions, g and h. So you want to write those down. And then my problem says find h minus g of 3. And if you look at the rules, I can rewrite that as finding h of 3 and then subtracting g of 3 from that. So same order, the h goes first, then the g. So I'm going to find h of 3 first. So h of 3, I'm going to write function h, so negative 2, and instead of writing x, I'm going to write 3 plus 1. Negative 2 times 3 is negative 6, plus 1 is negative 5. So that's my output for h of 3, so I want to remember that. That's the output that I got here. And then I need to find g of 3. So I'm going to take g of 3 equals, and remember I'm going to now use my function g, so x squared minus 1. And I'm going to write that down here without the x. So I'm going to take my input now of 3 in parentheses, just to be cautious. When I'm working with negatives, it affects the answer. So I'm going to get in the habit of putting a parenthesis around my input value. So 3 squared minus 1. 3 squared I know is 3 times itself twice, which is 3 times 3, which is 9, minus 1, and that's 8. So that's my output value for g of 3. So now I have negative 5 minus 8, and that's going to be negative 13. So each of these examples use the rules that you copy down on the last slide. So you want to make sure you have those in your notes and you review this video as needed when you complete the following tasks. Don't forget to write on the board, Miss JC rocks, when you are finished, and have a seat. Make sure both of you have completed answer sheets and all questions answered before doing so. Have fun.